This is CS1101 Lecture 7.1. Today we're going to be talking about two common entities when dealing with loops. That's the Fencepost and the sentinel loop, and also ending with a discussion on how to use random numbers in Java. Before we begin to talk about what a Fencepost loop is, let's look at an example that shows the need for this particular type of structure. So a simple problem that exemplifies this would be trying to write down all the numbers up to some number. So let's say we write a method. We'll write a static method that prints out every number from 1 up to some number that we have passed it as a parameter as the maximum. So if we give it 5, it would print out 1, 2, 3, 4, 5, and each number we want to be separated by a comma when it prints out on the screen. So let's try to, let's not even think through this. Let's just start trying to code this and see if it'll work. So we want to write a method that we can pass it a parameter max, and this parameter will be the maximum value that gets printed out to the screen. We print out all values from 1 up to that max value, separated by commas. Okay, the first reaction you may have is, well, how about a for loop? Well, that'll work, right? Because we want to do something for every number from some number to some other number. Logical, makes sense. And this is the loop section, and the top of the screen says loop. So, all good reasons why we might think of loops here. So we declare our counter variable I, and we initialize it to 1. And we say we are going to have as our test I is less than or equal to max. So as soon as I goes above max, we stop doing this loop. That's good. And our update is just increment I. Then inside the loop, we are going to print out I followed by a comma, and the comma followed by space. Okay, does this work? Is this a viable solution? Sadly, no. The reason is, if we think through this, let's say we pass it the number 5 as the max, 5 is the max, so the first iteration through the loop, 5 is the value of max, so we have I equals 1, and we test to see if 1 is less than or equal to max. Max is 5, yes, 1 is less than or equal to 5, therefore we do the first iteration of the loop. We print out 1 followed by a comma. We see that here. 1 followed by comma. Then we test to see, at that point we update, so 1 plus 1 is 2. So I is now 2. Is 2 less than or equal to max? Yes. So we do this again. Print out 2 followed by a comma. This is going to happen until we get to 5, at which point when we update, it'll be 6 and we no longer continue in this loop. However, notice we're printing a comma after every number. So when we print out this 5, we print 5 comma. In the previous slide, we wanted to have commas between every number and its previous number. However, we didn't want one to be at the end of the list of numbers. So this is not a solution to the problem that we came up with in the previous slide. So this doesn't work. Let's take a look at another solution. What if we printed the comma before we printed the number? That way, at the end, we would have comma 5. Does that work? Well, if we think about this just the first loop through, we know that it doesn't, because I is equal to 1, 1 is less than or equal to 5, we begin the loop, we print out comma followed by 1. So the first thing that gets printed out is a comma. So the result is something like this, comma followed by 1 up through 5. The end's good, but the beginning is bad. Up here, the start was good, but the end was bad. So the fundamental problem that we're experiencing is we're wanting to print out n numbers. So if we had a max of 5, we would want to print out a total of 5 numbers. So we're printing out n numbers. However, we're trying to print out n-1 commas, right? Because we want a comma to come after every number except for the last number. So n-1 commas. So this is a little bit like trying to build a fence. When you build a fence, you want to set a fence post, and then you want to connect fencing to the current post and the next post. So to build a fence that is 3 fence posts long, we want to actually only build 2 sections of fence. Otherwise, we have a dangling section of fence. So we have n fence posts that we want to set, but only n-1 sections of fence. Otherwise, we wind up with a piece of fence dangling with no post to connect to. If that's what we're after, this algorithm on the left is flawed. Place a post, attach some wire. Sounds good at first, but then you realize that you wind up with a dangling section of fence at the end, because we place a post, attach some wire, place a post, attach some wire. And then we want to just place a post, but we also wind up attaching some wire. So we need a way to do n operations of one variety, but also n-1 operations of another variety. The way to solve this is either to place an initial post so that one of our n occurs before the loop, so therefore we are allowed to do our loop n-1 times, or to place one of the posts after the loop, so that we're allowed to do the loop only n-1 times. That's why it's referred to as a fence post solution, because of this correlation with building a fence. Oftentimes it's also called a loop and a half solution. Loop and a half because you want to, on the last time through, not actually complete a full loop, but exit the loop and then do some of the loop actions outside. So a revised algorithm then that would successfully build a fence that is appropriate without dangling sections of wire would be place a fence post. So our first fence post is placed, and from that point forward our algorithm is simple. We want 3 sections of fence, so we're going to do this algorithm 3 times. Attach some wire, place a post. Attach some wire, place a post. Attach some wire, place a post. We wind up with 3 sections of fence and 4 fence posts. So here are 2 solutions to our printing numbers problem. So first of all, we could have printed the number 1 before we ever began looping. So we've declared our method here, public static void print numbers, and we have given a parameter called max. So this would be a plant the fence post and then begin to build the fence. So print the number 1, then start at 2 inside the loop and go to max. So here we would do 1, and then from that point forward it would be comma followed by number. So this would be referred to or known colloquially as a fence post solution, because we are placing a post and then inside the loop building a section of fence and placing a post. So our post here is printing out the number 1 without a comma, and from that point forward we build the fence, or we attach some wire and then put a fence post in. Wire, fence post, wire, fence post. And ultimately we wind up with exactly what we want. Mathematically what we're doing is we wanted n operations of print number, but we only wanted n-1 commas. So by putting one of the print numbers before the loop, we are now able to do this loop n-1 times, which is why we had to deduct 1 from our loop iterations. So now we do the comma and the print number n-1 times each. Another way we could have gone about this would have been to move printing one of the numbers to outside of the loop afterwards instead of before. So in both situations, in the top and the bottom, we are moving one of the n operations outside the loop so that the number of operations for both the comma, which is attaching the wire, and printing the number, setting the fence post, is equal to n minus 1. See, so that's what we're actually after here, is just making it to where the number of times we want to do this operation inside the loop is equal for both operations, both the comma and the print number. So we could have had the number print out after the loop, in which case we would have started from 1 and printed 1 and then followed by comma. So 1, comma, 2, comma, 3, comma, 4, comma, and then that would be the end of the loop because we did less than max instead of less than or equal to max. So as soon as this I becomes 5, is 5 less than 5? No. So we would exit the loop, we would come down to the statement immediately below it, and we would print out 5. Both these solutions would work. In my opinion, I like the bottom one better because in the top we wind up with this weird starting condition where we start on the number 2 rather than the number 1, and that's not very transparent, and it kind of makes you wonder what's going on there, and it seems like you're missing something. Down here it seems easy to understand exactly what they're going for. So let's make use of this idea of a Fencepost loop and write a method to print all the primes up to some number. So given 50, it would print out 2, 3, 5, 7, 11, 13, and so forth with the rest of this list. These are all the prime numbers from 1 to 50. To find the prime numbers, we need to write a method which is called count factors. Count factors is going to return the number of factors for a given integer. As an example, count factors of 60 would return 12 because there are 12 individual factors of the number 60. In order to write count factors, we're going to have to be able to tell if one number is a factor of another. So think about how you might do that programmatically. Another question that we need to answer is, once we have this method count factors, how do we tell if a number is prime? What does it mean for one number to be a factor of another? So in the case of 60, we know that the number 3 is a factor of 60 because 3 goes into 60 an integer number of times. In general, that is exactly the condition we need to meet. If any integer goes into another integer a integer number of times, so in all three of these spots we have integer, integer, and then integer, then our divisor, which is the number on the left, is a factor of the dividend because the quotient is an integer with no remainder. Well, in programming, how do we test for a remainder? Yay, the mod function. So we're going to use mod to see if a number is a factor of another. The way we could easily do this is 60 mod 3. If 60 mod 3 is equal to 0, then 3 is a factor of 60. And this is in fact the case, right? 60 mod 3 is equal to 0. So this is our test for is a factor. If the dividend modded by the divisor is equal to 0. What about count factors? How do we use count factors to know if a number is prime? What would count factors return for the number 7? 2. It would return 2 factors because every number has at least 2 factors, 1 and itself. So if we were to test every number from 1 to 7 by saying, okay, 7 mod 1, 7 mod 2, 7 mod 3, 4, 5, 6, 7. Okay, the only two numbers that are going to equal 0, the only two expressions which will equal 0 is 7 mod 1, that will equal 0, and 7 mod 7, that will also equal 0. No other number from 1 to 7 will give you a value of 0 for the mod function in 7 mod x. Only 1 and 7. So every number is going to have two factors. In that case, then we know that a number is prime specifically if a number does have two factors. So we can call count factors and see if the number returned is equal to 2. If it is, then it's a prime number. Let's look at that in code. So we have some class called primes that we've written, and we have our main function where we're going to call print primes up to the number 50, and then we're going to call print primes up to the number 1000. And then our method for print primes, we've documented it well. We are going to print all the prime numbers up to the given parameter, which we've called max. And notice here we have a precondition. Max must be greater than or equal to 2. So any sort of condition that we want to impose on what may or may not be passed as a valid parameter to this method, we have written in comments above the method. And as we go on, we're going to talk about putting these into Java docs so that it's a more standardized format, but not today, not in this lecture. So max must be greater than or equal to 2 because we aren't going to attempt to print out primes in negative space. So print primes, we have a parameter max. We return nothing, so the function or the method is void. And we are going to use a Fencepost approach to this. So in this situation, we're actually going to move some functionality to before and some functionality to after. The reason is because the actual Fencepost portion of this problem is printing 2 followed by a space and a space in between each number. But there's an additional requirement that we saw in the example printout, which was we wanted to start with a bracket and end with a bracket. So the bracketing of the entire list of numbers definitely doesn't need to be in the loop because it only occurs at the very beginning and the very end. So it makes much more sense to place one bracket at the beginning and one bracket at the end outside of the loop. Then the Fencepost solution is simply printing the first number before we begin to loop through all the other numbers and print out spaces followed by the number if it is prime. So inside this loop, we're going to go from 3 up to max. We're starting at 3 because we already know that 2 is a prime, and we're already going to print 2 out as a given. So we start at 3, go to max, and each loop, what we're going to do is we're going to call count factors on I. So we return the number of factors in 3. Is that number of factors equal to 2? Yes, the number of factors in 3 is equal to 2. So we would print out space 3. So now we have bracket 2 space 3. Then I takes on the value 4 because of our update. And is 4 less than max? Well, our max was 50. So yes, it's less than or equal to max. So count factors of 4 is going to return 3, right? 1, 2, and 4. Those are the numbers that when you mod by, when you say 4 mod by 1, 4 mod by 2, and 4 mod by 4, they all return 0. So this count factors is going to return 3, which is not equal to 2. Therefore, we will not print out the number 4. Then we'll move to 5. Now, let's look at our count factors method. Count factors is fairly straightforward. We are going to return an integer value, and we are given some number that we wish to know all the factors of. So we start by initializing our count variable to 0, and we begin to loop through all the numbers from 1 to this number. And for each I, we are checking to see if number mod by I is equal to 0, just like we discussed. And if number mod by I is equal to 0, then I is a factor of number. So in this case, if I is a factor of number, we are going to increment the count because we have found a factor of the number. When this loop completes, we know that we have found every possible factor for number, and I has taken on every value from 1 to number. And we return count. This is a related but altogether different idea. A sentinel loop is a loop that's going to repeat until a user types in a specific value or enters a specific input. So this is an event-controlled loop that is going to continue to do what it does until the user enters a very specific value or presses a certain key. This is a common programming technique, and it usually looks something like this on screen. Enter a number, and then usually in parentheses or some way to, some way to separate it from the rest of the instructions, -1 to quit. So this way the user understands they can either enter a number, or if they're ready to stop, then they can enter -1, and -1 is not considered one of the numbers which was entered, but rather is just a way to tell the program I'm done and ready to continue with another portion of this program. For in this case, we're going to print out the sum of all the typed numbers. This is sort of like pressing the X, right? So clicking the X to exit a program. However, that's a visual solution. In this case, where we're interacting with the user via the console, we need some way of allowing them to enter a value that tells us what they want. And loops are a pretty good way to go about that because, what we've said is we want to continue doing this thing until they type in a very specific value. So loops are great for continuing to do something over and over and over again. So then what we need to do is write a loop that specifically when a certain event occurs, we stop doing it. Good thing we've already talked about event-controlled loops. So this isn't much of a hurdle. This is just a very specific and useful type of event-controlled loop. So let's write a program that is going to prompt for a word or words until the user types goodbye followed by exclamation mark. When they type goodbye followed by exclamation mark, the loop will exit. So an example run would be type a word or goodbye to quit. They type Dawn, it asks them for another word, Kane, another word, Barney, another word, Mia, another word, and then finally they type goodbye followed by exclamation mark, and this loop will print out which word was the longest that they typed. In this case, it was Barney. Notice, actually, goodbye is longer than Barney. So let's consider a solution to this problem. We declare our scanner, call it console because we want to get input from the user. We're going to have some string to store our longest in and the word that we get from the user. And we've given it a dummy value, in this case, empty. We could give it anything, we just couldn't give it the value goodbye because we're going to test to see if it equals goodbye, and that's our test condition to exit the loop. So as long as word.equals goodbye is false, then we're going to continue this loop. Now let's look at what's inside it. We're going to prompt the user for a word or goodbye to quit this loop. We're going to get the new word from the console, which the user types in, and we're going to use the console.next instead of next line because we only want one word, so one token as a string, and we're going to assign that to word. Then if the length of the word is longer than the current longest, remember longest is that string that we declared to store whatever word is currently the longest. So if the length of the new word that the user typed in is longer than our current longest word, we'll replace longest by this new word. And we will do this until the user types goodbye followed by exclamation mark, at which point we will go to the statement immediately following the while loop and begin to execute there. We'll print out the longest word you typed was, and then whatever the longest word followed by the number of letters. Does it work? It sounds good. Nope, it doesn't. It doesn't work because when they type in goodbye, so it prompts for a word or goodbye right here. When the user types in the word goodbye, this word variable takes on the value goodbye followed by exclamation mark. Then we're checking to see if goodbye is longer than our longest word. So in the previous slide, Barney was our longest word, but Barney was actually only 6 letters long, while goodbye is 7. So in this case, what we're going to actually print out is the longest word you typed was goodbye, which is 8 letters, including the exclamation mark. So this is a bad solution because we're allowing goodbye to be considered as a candidate for the longest word. Let's look a little closer at the problem. We're using a pattern something like this. Longest equals empty string. While the input is not the sentinel, prompt for input, read the input, check if input is longest. If so, keep it as longest. But on the last pass, the sentinel is what we read in, and then we wind up checking to see if it is longest. And then it does become the longest if it's longer than the current longest. This is actually a Fencepost problem. This is actually sort of a complicated or semi-complicated Fencepost problem, because think about this. What we really want to do is read in words from the user, but we only want to check n-1. We don't want to check the sentinel. So we want to read in words, so all the words that are valid plus the sentinel, but we only want to check n-1. So we can use a Fencepost solution to solve this problem. So in this solution, we are going to initialize longest with an empty string just like we did before, but our new pattern is going to first place a post and then build fence internally just like we talked about before. So in this case, placing a post, remember, an easy way to remember what's the post and what's the wire, so to speak, you want to place in posts and only do n-1 wire sections. So we wanted to get in words from the user while only check n-1 times for if it's the longest. So then that means our post must be prompting the user and getting a word. And our wire is checking to see if it's the longest and storing if it is. So we place a post, we prompt the user and read the input, and then we begin our while loop. Is the input the sentinel? So notice right here, if the user had typed in goodbye exclamation mark, we wouldn't even check to see if there was a longest. It would just be nothing, and we wouldn't enter this loop, and we would skip to the end. Okay? But let's say they typed in something else. They didn't type in the sentinel. So we're going to check to see if the input is the longest. If so, we store it. So it is the longest, so we store it. Then we're going to prompt for input and read in this new input. Now what happens if the user has now typed in sentinel or goodbye followed by exclamation mark? Well, we just reached into the loop. After we reached into the loop, we go back and perform the test. So the user did type in goodbye followed by exclamation mark, so this test is going to come back false because the input is the sentinel. So when this test comes back false, we don't start another loop, we immediately jump to the statements following the loop. So notice now, if the user types in the sentinel, then we are not going to compare it to the longest, and therefore it won't be taking the place of the current longest word. So now we have moved one of our posts outside the loop to the beginning. So now internally we're able to do n-1, check for largests, and prompt for inputs. In the previous slide we looked at it in pseudocode, but let's make sure we understand it in Java as well. So we have our scanner object is declared. We declare our longest string and initialize it to being empty. And then we need to place the first post outside the loop. So we will prompt the user and get their first word. So we already have a valid user input in Word. Now we're going to test to see if this word is goodbye exclamation mark. If it were, then we're not going to do the contents of the loop, and we are going to jump to the end. However, let's say that it's not goodbye, then inside the loop we're going to check to see if this new word is longer than our current longest. It is, because the current longest is an empty string, and so longest is replaced by word. Now, let's say the user only wanted to type in one word. Now they type in goodbye exclamation mark when this next prompt occurs. So word is now equal to goodbye exclamation mark. We reach the end of the loop, we jump back to the test, and word dot equals goodbye exclamation mark is true. So we are inverting whatever the result of that Boolean expression is, and we wind up with false. If the test is false, we do not do the next iteration of the loop. So the sentinel never gets compared to the current longest, and we always have an accurate printout for what the longest word is without considering the sentinel. A better version of this would have used a class constant for the sentinel. This way, by doing this, if we decided to change the sentinel from goodbye to say done followed by period, we wouldn't have to go through our program and look for every instance of goodbye exclamation mark, goodbye exclamation mark, goodbye exclamation mark, and so forth. Rather, we would just be able to change the constant sentinel to done, and it would still function perfectly without having to search the code for random instances of this string literal. A further better approach would define a helper method to print out type a word or type the sentinel to quit, followed by getting the next input from the console. So if you were to put this in a method, you wouldn't have to type it in twice, and then you could just call the method here and here. So let's go back to our original example where we wanted to sum all the numbers typed in by the user until they entered -1. So does the solution below work? Declare console as a new scanner. Declare the sum variable and set it equal to 0. The current number, set it equal to 0. Then inside our loop, while the number is not equal to 1, or -1, we are going to prompt the user for a number, get the number, and then sum that number together with the current sum, and then jump back to check and see if we need to exit the loop. Does this work? Hopefully at this point you know the answer to that question is no, because we are getting -1 at some point. The user is going to type in -1, and we wind up with getting -1 as our number, as the value for our variable number. And then we're summing the current value of sum with this -1. So no matter what, whatever the value of sum is that we should return, we wind up with sum minus 1 being the actual value that is returned. Because we are including our sentinel in our operation. So let's look and see if there's a number of operations here that is mismatched. We want to get how many numbers from the user? Let's say that's n. So we want to get n numbers from the user. But we only want to sum n minus 1 because the last number that the user types in is going to be -1, and we don't want to sum -1 with the rest of those numbers that they typed. So we want to get n numbers, but we only want to sum n minus 1 numbers. The solution here is to use a fencepost loop so that we can move one of the operations out of the loop so that the number of get numbers is equal to n minus 1 and the number of sums is equal to n minus 1. So just from our short discussion about this situation, it should be apparent that this is our post. This is our wire. So a solution to this would be to plant a post up here, then wire, then post. So here is a solution using the pattern we just discussed. We will plant a post, so prompt the user for input. So post 1. We'll plant that post before the beginning of the loop. Then we will begin the loop and we check to see if number is not equal to -1. So here's our sentinel condition. Now we are going to place the wire. So as long as the sentinel condition is false, we know that the value which is in number is not -1, which means we do need to add it to the sum. So we're good to add to our sum. Now we need to get another number from the user. So we're going to do this loop n minus 1 times. So the getting the number from the user is where we continue to plant posts. Make sure you understand this example, and if necessary, pause the video, rewind, look at the problem and the original code that did not work, and then make sure you understand how to go from the code that did not work to this code in the Fencepost loop implementation that does work. This is a really common situation where one of the operations inside a loop needs to be moved out to before it so that you can wind up with the right number of posts and the right number of wire sections. If you go on to become a programmer, this is something that you'll deal with very commonly. And it's important that you get to the level where recognizing these situations is second nature. So now let's look at another tricky problem. Let's try to replace every occurrence of an exclamation mark with a period. However, consecutive exclamation marks we want to replace with a single period. So, hey, you are great would be replaced by, hey, you're great. Will the simple solution work? Probably not, but let's just think about it for a second. Let's say we have a method that returns a string and accepts a string as a parameter. And what this method does is just replace. So it uses the replace method, which is built into the string object, and it replaces exclamation marks with periods. No, because our hey followed by 3 exclamation marks becomes hey ... So what we want is just hey followed by a single period, even though what we gave it was hey followed by 4 exclamation marks. So instead of just taking off coding on this problem, what we need to do is we need to stop and consider what are the conditions and the cases that we're dealing with. So we need to consider the situations that we want to address, and we need to specifically also think about our edge cases. So phrases without any exclamation mark should remain unchanged. That'd be a good point to have in the map to understand that a string which we pass to our method with no exclamation marks should not be changed at all. If there's a single exclamation mark in different spots, it should be replaced correctly, regardless if it's in the first, middle, or last positions in a string. And then dealing with multiple exclamation marks in a single position. So three at the beginning, 3 at the end, it shouldn't matter. It should be able to replace multiple exclamation marks with a single period. So thinking about these edge cases and these situations helps us to understand what sort of functionality we need from our solution. Here's one approach to solving this problem. We can declare a temporary string, which is where we will build our new string that will return that is no longer including any exclamation marks. Initialize a counter variable we'll call I, and then use a while loop to go through the entire string until we have I greater than or equal to the length of the string. So the idea here is we're going to process this string one character at a time. In any place where we find a character that is not an exclamation mark, we will keep that character. So we will directly concatenate that character with our temporary string. When we do find an exclamation mark, we will follow an else branch. Inside this else, we're going to have a loop. What this loop is going to do is it's going to keep incrementing the value of I until we no longer have a char equal to exclamation point, or until we find the end of the string. So if we had the string I followed by 2 exclamation points, what would occur is the if from the previous slide would place the I directly into our temporary string. Then when we hit this exclamation point, so our index is 1, we will follow this else. Inside this else, we are going to see if we are at the end of the string and if we are equal to exclamation point. We are still less than the end of the string, and we have an exclamation point here, so we are going to increment I, the index. So the index then moves to the next exclamation point. Now, we will again check to see if we are less than the length of the string and if we are equal to exclamation point. At this time, we will find that when we increment, we are no longer less than the length of the string. So our while loop will terminate. We'll jump to the next statement, and we are going to concatenate a period with our temporary string. So the result is I period being stored in temporary string, and then we will exit this while loop altogether because we have found the end of the string and the result is I period. If it's unclear how this works, then execute this loop on paper, writing out temp string by hand, and do multiple cases. So do a situation where you start with exclamation mark and then have some stuff in the middle and some exclamation marks in the middle and one at the end. Do some where you have just exclamation points, and do some where you have no exclamation points. This is a good time to introduce the break statement. In 1101, you're not going to be allowed to use break statements. However, if you go on to take 2201, you will be allowed to use them. So this is more in the interest of you being able to read Java code and be aware of the existence of this break statement. What it does is allow a loop to be exited at any point. So rather than only exiting a loop via the test condition, we can instead have a loop be exited at any point by executing the break. So when the break is executed, it's just as if the test failed. We will immediately jump to the statements immediately following the while loop. This is often used either in a forever loop where we have the test condition is a true, so this can never be false, in which case this is just a infinite loop, but it is not actually infinite because we have a break used in the middle of the loop. The other reason that you will see break statements in code is for patches to fix poorly coded loops. It's best to learn without using them, so for this reason in 1101 you're not allowed to, but in 2201 you'll be allowed to use them properly. So here's a situation where someone might use a break statement to solve a problem that would be better solved by coding it correctly. So if you were attempting to do what we did before, which was sum together all of the integers which a user types in, and then allow them to exit whenever they type in -1, if a programmer was not aware of how to code a Fencepost loop, perhaps they might go about it in this way. A while loop, which is always true, and then they prompt the user, get the input from the user. If the input is -1, break. If not, sum. And then just continue this until the user types in -1. This code works. However, I would call it hacky. So it's as if they didn't understand how to solve this problem in a more straightforward way, so they sort of hacked it together. The obvious solution here is to get rid of the break statement, put the sentinel into the test for the while loop, and then move the prompt outside as we did before as an initial post, and then continue from that point with a typical wire then post loop execution. So here we have our rewritten version back to what we had discussed previously. We have our post 0 or post 1, call it post 0 here. And then inside our loop, we have summing the values. So this is wire. And then we have post. So in this way, we needed to do n number of get input from users, but we only wanted to do n-1 sums. So we get an initial input from the user, check to see if it is the sentinel. If it's not, then we're going to sum it with our current sum, and then get another input from the user, and then check to see if it's the sentinel. So in this way, we have fixed the Fencepost problem and moved our initial post outside the loop, and continued that from that point on inside the loop with a wire then post format. So we didn't need the break statement. The break statement was really just there because it was originally coded non-optimally. This is a good time also to bring up random class. So the random object is going to generate a pseudo-random number, and this random class is part of the java.util package. So if you've been using the java.util.scanner import, you can just change that to java.util.star, and you'll also be importing the random class as well, so you can make use of random numbers. Common methods that are used from the random numbers class: nextInt is going to get a random integer. you can give nextInt a parameter of max, in which case it will return an integer between 0 and max minus 1 inclusive. Another one that's used pretty commonly is next double. So this is going to return an integer, sorry, it doesn't return an integer. It's going to return a double from 0 to 1, and that is inclusive of 0, exclusive of 1. It's pretty easy to work with the random numbers in Java. Just remember that, like string class, we're starting at 0. So if we do ran.nextInt, then we're returning an integer from 0 to max minus 1. So it has 10 possible integers it will return, but those 10 are 0 to 9. So if we wanted to generate, say, a die roll, or simulate a die roll, then we would need to use ran.nextInt with a max of 6, but that's going to return a number 0 through 5. So to make this 1 through 6, we need to add a offset. So then we're going to return a number 1 through 6. We can generalize this and say that whenever we want a number between min and max inclusive, then whatever the maximum value is, minus min plus 1 is the size of the range, and min is obviously the min value. So we can use this formula to generate random numbers on an inclusive range of any minimum to maximum. So we would call nextInt, and then the size of range is max minus min plus 1 plus the minimum value. So if we wanted to generate a random number between 4 and 10 inclusive, we would do 10 minus 4, 6, plus 1, 7. So ran.nextInt of 7 plus the min is 4. If you think about this logically, this makes sense. NextInt is going to return an integer between 0 and 6, and we wanted this integer to be between 4 and 10 inclusive. So 0 plus 4 is 4, 6 plus 4 is 10. Now we have an integer between 4 and 10. Here's a mini exercise to make sure you understand how to get a random number between a given min and max value. So at this point, pause the video and solve these problems and see if you get the answers correct. So in this first problem, we wanted a number between 1 and 100 inclusive. Very easy. We would do, if we wanted to follow the formula, we would do max 100 minus 1 plus 1, so range of 100. And then to put this into code, it would be rand.nextInt of the range, which we just found to be 100, plus the min, which is 1. We can do this logically in our heads because this is a simple situation. We know that ran.nextInt is going to return a value between 0 and max, so this would return a value between 0 and 99. We want it to be between 1 and 100, so we add 1. In the next situation, we want to generate a number between 23 and 30. So following the formula, 30 minus 23 plus 1 is going to be 8. So we will do ran.nextInt of 8 plus the min, 23. Finally, we want a number between 50 and 100. So we would do 100 minus 50 plus 1, which is 51. In which case, we have ran.nextInt of 51 plus the min, which is 50. So let's do an example situation where we want to write a program that's going to be similar to a game of chance where the user's rolling 2 die until they roll until the sum of the die roll is 7. So if we were going to code this, what kind of loop do we want to use? How many random numbers are we dealing with? We could use a for loop, but a while loop is better since this is definitely an event-driven situation because we want to stop looping whenever the sum is 7. We'll need 2 random numbers, one to represent the result of each die roll. However, we don't need two random objects because we can get both numbers from a single random object. An example run of our program would look something like this. We generate a die roll and it gives the value 2. Another die roll gives the value 4. The sum is 6. Die roll 1 gives 3. Die roll 2 gives 5. Result is 8. 5 and 6, 11. 1 and 1, 2. 4 and 3, 7. On the 5th try, you won. So to code this, first of all, we need to initialize and declare a random object. So we declare a variable called rand of type random. Notice we're importing java.util.star. And we are assigning our rand variable a new instance of the random class object. So we create one random object and assign it to our rand variable. Then we're going to declare an integer variable called tries and an integer variable called sum. And then our loop is going to continue until sum is equal to 7. So as long as sum is not equal to 7, we are going to continue to loop, and we're going to keep track of how many tries we execute. So we're going to do a increment on tries. So inside the loop, we'll also declare roll 1 and roll 2. Notice we can declare it inside the loop because we're not going to make use of roll 1 and roll 2 when we exit the loop. So roll 1 is going to be assigned the value which results from a die roll. And the way to simulate a die roll is to generate a random number between 1 and 6. We know that the rand.nextInt method is going to return a value between 0 and max minus 1. So we need to add 1 to it to get the range from 1 to 6. So roll 1 will be a number between 1 and 6. Roll 2 is also a number between 1 and 6. But this is a separate call to rand.nextInt. So therefore, this is going to generate a separate pseudo-random number. So this is the reason we didn't need two random objects. One random object will do it because each call is going to generate a different random number. Then our sum is going to just be the addition of roll 1 and roll 2. We increment the number of tries because this is, in this case where we're executing this loop, we have just rolled the dice for our first time. Tries was 0, now it's 1. We can print out roll 1 plus roll 2 equals sum to give the output we saw on the previous slide. So assuming that this is not equal to 7, we will again return to the first statement and we will begin to execute. Then when the sum of roll 1 and roll 2 is 7, we will test and the test will fail. And the program pointer will jump to the statements immediately following the while loop, and we'll print out U1 after tries, which we've kept track of. So this is the way that we would implement the functionality for a game of chance where we're trying to roll 2 die and see if the sum is 7. Another example program to do would be a tutor program. Here we want to print out two numbers to have the user attempt to multiply together, and then they are to type in the answer, and if they get it correct, we print out correct. If they get it wrong, we print incorrect and give them the correct answer. So rather than having just a static list of numbers to have the user go through, rather it would be better to generate these numbers randomly. That way, each time the user goes through the tutorial, they get a new set of numbers and they are generalizing their knowledge. So here's an example run of the program. 14 times 8, 112. They got it correct. They get all these correct until 256, which they think 19 times 14 is 256. We say, nope, the answer is 266. Once the user gets one of the questions incorrect, we exit the loop. So that is our sentinel condition. So an incorrect answer is the sentinel. So here's the solution to this multiplication tutor problem. We would import java.util.star because we want to use the random class. We've called our class multiplication tutor. And inside our main, we have declared a scanner, but we only have one scanner because we don't want to crash Zybooks or some other compilers as well. And we have made our rand object. So now we need to keep track of the number of correct answers, and we also want to have a variable called last correct so that we're able to print out the last correct answer that they gave. Now we're going to use a Fencepost solution because we have n number of questions we want to ask, but only n minus 1 increments of the number of correct answers, because the last one they will get wrong, which will be the sentinel condition, and therefore we should not increment correct. So this is a Fencepost solution where our Fencepost is asking the question and the wire is the increment of number of correct answers. So we have inside our while loop, we have our sentinel condition, which is that the last is not equal to -1. Last is where we're going to store the result of asking the question and the user answering the question. -1 means they got it wrong. So as long as last is not equal to -1, the user didn't get it wrong, which means last correct should be equal to last, because last correct holds the last value that they entered correctly. And then we need to increment the number of correct answers given, and then we ask another question, and we will return the value of their answer into last. That is assuming that the value of their answer was correct. If the value of their answer is incorrect, then last will take on the value -1. So understand, ask question is going to return either the value the user typed in or -1 if they got the answer incorrect. Then we print out, once they get one of these questions wrong, the -1 will be the value of last. So at that point we'll stop executing the loop and we'll jump to the following statements. We'll print out you solved and then however many they got correctly. Then we'll print out if they got more than 0 correct. So if they didn't miss the first question, we will print out the last correct answer and then last correct as well. So now let's look at the internals of ask question. So inside ask question, we have a parameter called console, which is how we're going to get the input from the user. That's the scanner that we declared in the main. We're going to pass it into this method. And we have a random object called rand that we're also going to pass into the method rather than creating another random object inside this method. So now we need to get 2 random integers to multiply together, which will store in num1 and num2. So to keep it simple, we will have these integers generated on the range from 1 to 20 inclusive. To do so, we need to have a max given to the next int method of 20, but that'll return a value of 0 to 19. So we need to add 1 to shift the range to 1 to 20. We do the same thing for num2. It's another call to rand, so this returns a separate random number. So at this point, we are going to print out num1 times num2 equals, and this is a prompt. So we are not going to use a print line because we want the user to type behind the equal sign. So we use a print statement, not a print line statement. Then we're going to use the console object, which is a scanner object, to get the next int, and we're going to store that into guess. That's where we're going to store the user's guess. Now notice, if the user types in a character such as a or a word, something like that, this is going to crash. So we're not doing input validation here. We expect the user to do what they should. In general, that's a bad expectation, but to keep things simple on the code we're talking through, We're just going to expect them to do the right thing and give a number that is actually a number. To see if they got the answer correct, we simply compare guess to num1 times num2. So programs, or computer programs and computers in general, are very good at doing simple arithmetic. So this is an easy comparison to be able to tell if the user's answer was correct. If it's incorrect, we will print out incorrect, and the correct answer was, followed by the correct answer. We will then set guess equal to -1. This is so that when we return guess either has the value they typed in, which was correct, or -1 if they got it incorrect. One of the biggest uses for random numbers in computers is simulations. So sometimes mathematicians can develop closed form solutions for probabilities. So we could easily calculate the probability of 2 dice summing to 7. However, it's much more difficult to come up with a closed form solution for the probability that it will rain tomorrow. So in these situations where we don't have closed form solutions, and even in some situations where we do, a good solution is to simulate the environment using random number approximations. Computers are perfect for these random number trials to see what the probability of a specific outcome is going to be. These are called Monte Carlo simulations. A lot of the research and efforts that have been put toward predicting how the coronavirus pandemic is going to unfold has been based on models that have been run over and over and over again to see what happens, and then they develop probabilities for each of the outcomes. So if in one of the outcomes, the hospitals become overloaded, and in another outcome, nothing happens and everything's fine, they look and see how often those two outcomes occur, and that helps them to get a sense of the probability of each of the outcomes.